Hi everyone, I am C. Ramesh, Assistant Professor, Department of Electronics and Communication Engineering, KIT, Karnaugh Institute of Technology, Coimbatore. I am going to present about simplification of Boolean functions by using Karnaugh map or also called as kmap. There are some of the techniques to simplify the Boolean functions, but the most familiar techniques are Boolean theorems, kmap simplification, tabulation method. In this presentation, it gives the kmap simplification. Introduction. The truth table representation of a function is unique. When expressed algebraically, it can appear in many different forms. But the Boolean functions may be simplified by algebraic means. However, this procedure of minimization is difficult because it takes specific rules to predict each succeeding step in the manipulative process. The kmap method provides a simple, straightforward procedure for minimizing Boolean functions. First of all, what is meant by kmap? A kmap is a graphical representation of a truth table that can be used to reduce a logic circuit to its simplest terms. It uses a rectangular boxes divided into rows and columns. Each box in the cell is called as a cell. Any product term in the expression to be simplified can be represented as the intersection of rows and a column. The rows and columns are labeled with each term in the expression and its complement. The labels must be arranged so that each horizontal or vertical move changes the state of one and only one variable. First, n variable kmap contains 2 power n boxes or cells. First, 2 variable kmap. So it contains 4 cells. We take the variables as x and y. So we represent the variables in the kmap as minterms. So first minterms is 0 and the second one is 1 and third 2, fourth cell is 3. So and we represent variables as 0 and 1, both the variables. Then 3 variable kmap. 3 variable kmap consists of 8 cells. We represent the minterms as m0, m1, m2, m3. Here the variable changes from only one variable. So we have write it as a second variable, third variable as a 1, 1 and then 1, 0. Next one, 4 variable kmap. 4 variable kmap consists of 16 cells. That is m0, minterms as m0, m1, then again m2 and then m3. Because there is a one bit or one variable change from one adjacent cell to another adjacent cell. So we have to write here as 0, 0, 1. So we have to change the variables as 1, 1. And the next minterm is m4, m5 and here m6, m7. Then in the columns also we have to follow the same procedure. So we have write the minterm m8 as in the last row and then followed by m9, m10, m11, m12, m13, m14 and m15. Next one, simplification using the kmap. Look for the adjacent squares and then adjacent squares are those squares where only one variable changes as one moves from a square to another. Group adjacent squares in powers of 2, that is pairs, quads, groups of 8, groups of 16, etc. The first principle is the more the merrier. Hence a quad is better than a pair and the quad is better than, Next principle 2, share group elements only when necessary to form another or bigger group. Consider the example, function a comma b, two variable kmap, function a comma b equal to summation minterms 1, 2, 3. So write the minterms as 1 in the kmap. So we have to group two adjacent pairs, first in horizontal and in vertical. So we consider the vertical function as vertical function as b and the horizontal term as a. And another example, function a comma b, summation minterms of 0 and 1. Here 0 is represented as 1 and that minterm 1 is represented as 1. Here the value output of the function is a bar. The output can be written by seeing the corresponding variable, whether it is complemented term or non-complemented term. Next one, 3 variable kmap. The variables are x1, x2, x3. Summation minterms 0, 1, 2, 3, 6. So we have to mark the cells as 1 according to the minterms. Here the possible adjacent pair is quad. So we have to circle the quad first row as a quad. So we have to write the function as f equal to x3 bar only. The variable is x3. So we have to write x3 complement term. Plus next one more possible pair is there. It is a two adjacent pairs. It is termed as, its value is 1, 0. So we have to write as x1, x2 bar. The next example, function f of x1, x2, x3 equal to summation m 2, 3, 4, 6. It's a minterms. So in this kmap, we have seen the another possible groups. The another possible group is a two adjacent groups in the first column and last column. There is a option to group like first column and last column, but we can't able to group first and third one. Next one, it's a 4 variable kmap. 4 variable kmap consists of 16 cells. So here the function is given as a Boolean expressions. Here first function a bar, b bar, c, d. It's a term 3, minterm 3. So we have marked it as a 1. So next one, a bar, b, c, d. So a bar, b, c, d. So here we have marked it as 1. The same way we have marked the remaining ones. So here we have to group. There is a possibility to group quad pairs and then quad pairs only. So we have to group quad pairs in vertical and in horizontal. So the function f is ab. The columns consist of different values. There is no common values in the common variables in the column. So we have write the function as ab plus cd. Next one. One more example for 4 variable kmap. Variables are xy, w, xy, z. As the same way we have marked 1 for the given minterms. We have to group in quad and 2 adjacent pairs. First quad, we have write it as a b and then pair, 2 adjacent pairs as a. The function output is a plus b. So we have write the common terms for a, for the row we have write it as w bar x bar and columns as there is a 2 columns. So we have to write the same variables which does not change from one column to another column. Here y is does not change from first column to second column. So we have to write as a y bar plus b term. B term is here b term is corresponding rows. You have to see the corresponding rows. Corresponding rows. W does not change for say third row to fourth row, but x changes from 1 to 0. So we have to write only W. And then see the columns. Here y does not change, but z variable changes from 1 to 0. So we have to write only y. Next. There is other possible valid groupings of a 4 variable kmap. These are the possible groupings in 4 variable kmaps. One more condition is there in the kmap, that is called don't care condition. It is input combination that will never occur, so the corresponding output can either be 0 or 1. Don't care conditions can be used to help simplify Boolean expressions further in kmaps. They could be chosen to be either 1 or 0, depending on which gives the simpler expression. We usually use the notation summation d. D is don't care to denote the set of don't care minterms. For example, the function p in the odd parity generator for BCD, that is binary coded decimal, can be written as p equal to summation m minterms 0, 3, 5, 6, 9 plus summation d 10, 11, 12, 13, 14, 15. In BCD, we can't able to denote as 10. So we have to stop that, consider the after 9 as a don't care conditions. Let's see this example for comparisons. We consider the example for don't care and with don't care and without don't care cases. First, without don't care conditions, the number of ones for the corresponding expressions are placed in the kmap. We can't able to group the ones, number of adjacent ones. So we take it as a one pair, one, and then we can write as a expressions. With don't care conditions, after 9 for BCD example, we have write it as a x. For don't care, we consider x. Here, always give preference to the maximum possible adjacent pairs, that is quad. So here we consider it as a. In here, only one term is there. So we consider don't care to make maximum pairs. So here quad is possible by using the don't care. In the same way, we can use these pairs. Before we have seen the sum of product simplifications of kmap. Here, product of sum simplifications is also available. Let us take the example. Function a, b, c, d is a 4 variable kmap. Summation 0, 1, 2, 5, 8, 9 in sum of products and product of sums. If we have to consider the product of sum, we have to take zeros only, not ones, and write as a term, write the answer output as a plus b into c bar plus d bar into b bar plus d. Thank you.